Hello, hello, hello. How's it going? Welcome back to Business Statistics. So today we're going to start chapter 5, which is about discrete probability distributions. So let me share my screen with you, and then we can start chapter 5. So here we go. What we're going to talk about today. So today we're going to talk about, of course, the probability distribution for a discrete variable, and we're going to define what are random variables. So random variable is a numerical description of the outcome of an experiment. Remember from probability that from experiments, we always have an outcome. So a random variable then is going to be a numerical description of that outcome. This random variable can be classified into two: discrete random variable and continuous random variable. A discrete random variable may assume either a finite number of values or an infinite sequence of values. And a continuous random variable may assume any numerical value in an interval or collection of intervals. So we're going to focus on discrete random variables because, again, it's a discrete probability distribution. Since a discrete random variable can either have a finite number of values or infinite number of values, then let's take some examples about a discrete random variable with a finite number of values. For example, rolling a die. The random variable is the number of dots showing on the top of the die. So the possible values for this random variable can only be 6. So that's why it's a finite number of values. Can either be 1 or 2 or 3 or 4 or 5 or 6. Nothing different than those 6 possible values. However, when an experiment might provide an infinite number of values, then of course we cannot limit the possible outcomes. So for example, managing a healthcare clinic for one day. If X is the outcome and is defined as the number of patients arriving one day, X can take on values like 0, 1, 2, and so forth, so on. Of course, not necessarily we're going to have infinite number of patients arriving in that particular day, but we can count the patients arriving. However, the upper limit is not limited to the number that might arrive. So that's why we define that as a infinite number of values. So some other examples: family size. My random variable is defined as the number of dependents reported on a tax return. That type is discrete. Another one is the distance from home to stores on a highway. We can define the random variable as the distance in miles from home to the store site. Again, it's a continuous type because, again, this random variable is measured as miles and not counted as, for example, the number of dependents. And then another example is whether you own a dog or a cat. So my X or my random variable could be, well, 1, if I define that I don't own any pets. 2, if I own dogs, equals 3 if I own cats, and 4 if I own dogs and cats. It is considered a discrete random variable because, again, I can count and I can classify whether no pets, only dogs, only cats, or dogs and cats. Okay, and with that I can say ciao for now. However, before ciao for now, don't forget to take your quiz about checking your understanding. And my next lecture is going to be about discrete probability distributions, definitions of it, and how you calculate mean and variance. I'll see you in a bit.